Hi everyone, welcome back. Differential equations number 2. Easy as a maths teacher to go more and more tricky and harder, and I'm trying to resist the temptation to do that and go further. Let's have a look at these ones and watch how easily they fall out. How do we solve a differential equation? We separate the variables. We get all the y values on the left hand side normally as a habit, and we get all the x values on the right hand side as a habit. I do talk about we're creatures of habit. So if you do things by habit and you're under stress in an exam, you will default back on your training, you'll default back on your habits. So let's get all the y's on the left. So how do I get rid of a cos y from this side? If I times this side by cos y, I times that side by cos y. I keep referring to the opposites to both sides. So the opposite of divide by cos y is times by cos y. If I do it to that side, I do it to that side. Now some of you will just do that in your head. You would have looked at the question and go, that's cos y of x cubed dy dx, and you just go straight to that being 6. And you'll even go a step further, or a lot of steps further. So you can instantly go to this if you wanted to. I could go, well, there's my cos y, and let's say I left that x cubed there for the moment, times x cubed dy. Now those cos's cancel each other. Cos y and cos y cancel, and you're left with a 6. And then the dx can go to the other side and just become a dx thing. So let's have a look at what we got now. If I want to get rid of the x cubed, I divide this side by x cubed, I divide that side by x cubed, and then they cancel, and I've got cos y dy equals 6. Now I'm going to write this at the moment, this will be handy in a moment, as x to the minus 3. If I move it from the bottom of a fraction to the top, the index changes its sign. So then I've got that with a dx. So now I have all the y's on the left, I have all the x's on the right, so I can get the integral of both sides and just do normal integration. Turn something look quite revolting into something that's very, very simple. So what's the integral of cos? Sine will give us a cos when you differentiate. So sine y would give us a positive cos. I could put plus c. I'm going to stop writing plus c there, I did it in the previous videos. Now I'm doing the i's, so when we're integrating, we increase the power. Of course, this one we didn't increase the power, there's no power to increase. That applies to the question. So this will be 6x to the minus 2, and it's so easy to write minus 4. So watch out, we're increasing minus 3 becomes minus 2. Divide by the power, your basic principles of integration. And then we go plus c. Instead of putting plus c on both sides, I just put it on one side. So now we've got sine y is minus 3, and then the x to the minus 2 goes back to the denominator, and it changes sign, so that's x squared there plus c, and there's our general form, the general solution to the equation that we had up here. So in other words, general solutions meaning that we've taken the dy and the dx out of the question. Now we've written the equation as a relationship between the x's and the y's. So let's have a look at this one over here. Looks a bit worse. First thing I want to do is just go 2 plus 3e to the 2y, bracket, remember the brackets all the time. So many students leave it out. I presume it's the same in other countries. That students everywhere. I've had students from Korea, from Brazil. I've taught people from everywhere, but so many countries when they're visiting Australia or they've moved to Australia. And I see the same problem no matter what country people are from. So now I don't want the x on this side, so it's the only thing out of place. So I can put 4x plus 1. I really should put a bracket and put the x. Don't really have to there because of the nature of the x, but we'll leave it there for the moment. Now I can take the integral of each side. Integral of this side, because I now have only y's on the left, I have only x's on the right. So how do I get the integral of that? 2 becomes 2y. Now, e's, I always say to people that e's stay the same. So I write the whole expression just as is, and you've got to remember to divide by the 2. And I refer to that all the time, most people do, as the derivative of the inside. And what I'm talking about with inside is this e here has a bracket around it. Inside the control of the e is this 2y in there. And that's what I refer to as the inside. So we divide by the derivative of the inside. And if you want to see more on that, you can look at some of my equations on differentiation, my videos on differentiating and integrating. if you want more on that. I didn't bother putting the plus c, because I'm going to put it on the other side instead. 4x becomes 2x squared, so it's 4x with a squared divided by 2 becomes just a 2x. The 1 just becomes an x, and then we've got plus ac. So there's our equation basically done. Should we tidy it up? Could we tidy it up? There's not much to do. Some people may choose to go 2y plus 1.5e to the 2x squared plus x plus c. It's all personal choice whether you prefer fractions or decimals. I do say to people as much as possible leave with fractions. When people go to decimals, I see many students make silly mistakes, rounding off errors and inaccuracy, and it'll cost them mistakes in their final answer. So there's a couple of more simple examples. Next video we'll go a bit further. Thank you.